This video is meant for Mrs. Rose's AB Calculus class, and it is an example of a free response question about an application of integrals. Alright, we have an intersection in Thomasville, Oregon, where cars turn left at a rate of L of t equals 60 square root of t times sine squared of t divided by 3 cars per hour over some interval from 0 to 18. The graph of L of t is shown on the right. To the nearest whole number, find the total number of cars turning left at the intersection from 0 to 18. So, since we were given L of t, which is a rate at which cars turn left, in order to figure out the amount, the total number of cars turning left, we are going to look at the area underneath the curve of L of t. So, if we're going from rate to amount, so we're going to integrate the area from 0 to 18. So we're going to write the integral from 0 to 18 of L of t dt, or you can write out the actual function. Now, your calculator can actually integrate this for you. So we're going to go to our 84 first, and we can go to Math, scroll down to where you see fint. So function and then integrate. We're going to click on that, and then we're going to type in the function. After the function, you're going to type comma x and then comma 0, your lower limit of integration, comma 18, and then close your parentheses, then press enter. While that's calculating, we're going to go to the Inspire and show you here. We're going to press the menu button and go to Calculus and go to Numerical Integral, where we can type in 0 to 18 and then type in our function like so. And since I changed the variable from t to x, I'm going to write dx and then I'm going to press enter. I did something wrong. The answer is supposed to be this. Hold on a second. The angle is supposed to be in radians. So let's try that again. So we'll go up, click that. There we go. So our answer for both functions, whether you use the Inspire or the 84, we have 1657.8. And we're going to round to the nearest whole number because that's what the graph said to do. So our answer is 1,658 cars. Now this is worth 2 points. We get 1 point for the setup, the integral, including the interval and the function, L of t or written out, and then we get 1 point for the answer with units. Alright, part B. Traffic engineers will consider turn restrictions when the rate that the cars turn left is greater than 150 cars per hour. So find all the values of t for which L of t is greater than or equal to 150 and compute the average value of L of t over this time interval. Indicate units measure. So for all values greater than or equal to 150, I'm going to draw a line at 150 and find these two intersection points. So on my calculator, I'm going to go to y equals, and I'm going to graph the function, and I'm also going to graph y equals 150. For my window, I'm setting my x's from -2 to 21 with a scale of 3, my y's from -25 to 250 with a scale of 50, and I'm going to go to the graph. So from here, I'm going to be able to find my intersections by going to second trace and intersect. And we want to go a little closer. So our first curve is here. Our second curve moved to the right is here. We're going to guess. Of course, the y value is 150, but the x value is 12.4283. So our r is going to be 42 12.42831. And then for our second point of intersection, get a little closer. Here we go. And our second point is 16.12166. So L of t is greater than or equal to 150 on the interval from 12.42831 to 16.12166. I'm going to call this R and this S. You get 1 point for having the correct time interval when the function is greater than or equal to 150. So we've now found all the values of t where this is true, and now we're going to compute the average value of L over this time interval. So the average value is going to equal 1 over b minus a, or s minus r, from the times the integral of r to s of L of t dt. So we're going to go back to here and go back to our original. I'm going to do second inter to get the same function, and this is going to be 12 point, what were our x values? 42831, 42831, and our upper value is 16.12166. 16.12166. Close that parentheses. And we get this. Now, we're not quite there because we need the average value, so we're going to multiply this by 1 divided by b minus a. 12166 minus 12.42831. And we get 199.42. So the average rate of change is 199.426 cars per hour. We do the same thing on the Inspire. We can have this, but we're going to change our limits of integration, 16.12166, and the bottom one was 12.42831, and up in front we're going to do a fraction, 1 over 16.12166 minus 12.42831. And we also get 199.406, slight variation, but I think we can still count that. Is that close? Oh, I see my mistake. I put the wrong decimal in up here, so we'll just go up and we'll fix that decimal. Ah, there we go. 199.426 cars per hour. And for scoring, we get 1 point for doing the average value integral and 1 point for the answer with units. For part C, we have 4 points left, and they're all going to be used up here. We got traffic engineers will install a traffic signal if there is any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. In every 2-hour time interval, 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? Explain the reasoning that leads to your conclusion. Well, if we need the product of the total number of cars turning left and oncoming cars traveling straight is 200,000, if we divide 200,000 by 500, we're going to get 400. Oops. Go to, let's delete that and put an extra 0. Alright, so that's 400. So, since the rate that we're given is in terms of cars per hour, if we need 400 cars over 2 hours, we need 200 cars for 1 hour. So I'm going to draw a line at 200 and find these two intersection points. So this time I'm going to do it on the Inspire, since I already showed you how to find intersections on the 84. So we've got the graph, and I'm also going to graph 200. Okay, so there we go. So we have a little bit of area here, and to find the intersection I'm going to go to Analyze Graph Intersection and left upper bound, right bound, and then for the other point, same thing, intersection, and it looks like I'm going to need to move my points. Okay, so we have those two. Let's see, let's go to menu, settings, when I float, there we go. So we've got our 3 decimals that we need. So we have that the number of cars turning left will be greater than 400 on a 2-hour interval if the L of t is greater than 200 on that interval. So we get a point for considering that. And then we know that L of t is greater than or equal to 200 on this interval. So we get a point for that. And then what we are going to do is give one possible 2-hour subinterval. So if we look at 13.253 and 15.323, you really just need to give any 2-hour interval that would work with it with those decimals. So I'm going to say 13.3 to 15.3 like the Inspire gave us. So that's a 2-hour interval. And then our final answer is yes, a traffic signal is required because the integral from 13.3 to 15.3 is 435.83, and we can do that by integrating on our thing. Let's do this actually. And we're going to integrate from 13.3 to 15.3, close, delete everything else, and press enter. So we get 435.839, and if we multiply 435 times 500, that's more than 200,000, so a traffic signal is required. We get a point for an answer, yes, its traffic signal is required, with some explanation. Thank you for watching this video. I can't wait to talk about it in class, and good luck with the rest of your homework.